All right, so picking up on morning number 2 here, I am going to make an effort to be posting the videos at least every evening. I have work after these things, so probably not real soon in the day, but there's yesterday's video, and we are picking back up this morning, and we'll see if perhaps I can stay a little bit more on topic here. So yesterday we had been starting, we introduced some things that you can do as diversions if your mind gets tired or you just want to kind of learn these things by viewing them more as a game. I'd argue that that's a favorable practice rather than trying to force memorize things. And then we started talking about some of the initial, what I would call the very basics here. So we talked about variables and assignment operators. We talked about data types, specifically immutable data types. So things that you can't change things in. And then we talked about mutable ones. And for now, we're just going to be looking at two lists and dictionaries. These are collections in Python. Most languages have a list type of object, which you can modify. So you can add things to the list, remove things from the list, change the values of things at different indices in the list. And as in most programming languages, we saw here that you can change the value of things at a specific index in the list using the brackets. This is normal. You can do this in most programming languages that implement a list data type. And then dictionaries, we'll get to a little later. We will do some examples with them. Dictionaries are very, very useful, and Python dictionaries in particular. Most languages have something similar to this. Many languages will call it a map, not a dictionary. And they let you use things as keys to bind to values. So you access values by using a key. And we won't get into all of the backend specifics. So for example, lists commonly implemented by a data structure called a linked list. And what that means isn't going to be super important to us right now. This deals with, does it use contiguous memory addresses in physical memory on the computer, or does it use pointers one from the other? Linked lists actually use the second option, but this is one of the benefits, like I said, of me being able to teach programming how I wish I'd learned it. We're just not going to talk about any of that. If you're ever interested, feel free to ask about it, but I'm not going to have us spend a lot of time there because guess what? Day to day, I don't really care. There are pros and cons to various data structures. Some are faster than others, use less memory than others, things like that. But for us as day-to-day programmers, when we're using a computer system, the people who design programming languages and the compilers and stuff, they're really smart. And so they're going to optimize your code. As long as you don't intentionally do things that are really silly, your code's going to run just fine performance-wise. All right, so that's that. We talked about variables, data types, immutable data types. We did talk about indexing yesterday as well. That's an index. You can assign things by the index. We also talked about slicing. So what it means if I put a 1 there is we're going to get everything after the first index up to, but not including whatever we put after the colon, right? So this would get Audie and Jane because this is index 0. So we're going to start at 1. That's 1, 2, and 3. So up to, but not including that. So if we run this, we should get Audie and Jane. So we talked about that yesterday. Python has this very nice syntax to do this. Many other programming languages do not, which makes it a little bit more challenging. But indexing generally works like this. And Python has this cool thing called slicing where you do that. So you can assign data to indices like we saw here. This is reasonably common. Another good thing to note here, we don't quite have an example of this, but let's see. We can modify this list here for X, right? So if we modify just our scratch code here, and we said that if we do this, this changes Stephen to Jane. I guess this would be a good example. You can have quote unquote duplicate data in things too, because the thing that's stored at this index in the list is actually not the same thing as what's stored in this index. Now we said that strings are mutable, but these two things actually represent different things in computer memory. So this would be like if you have marbles and 3 of your marbles are green and 2 of your marbles are blue. Well, of the 3 green marbles, they may all be green, but they're actually not the same marble, right? They just happen to have a similar characteristic. That's the same sort of thing that we're going to be talking about here. So if we now, we'll just print X underneath this, we should probably do it in the same order so it's not confusing. Well, here we should have Jane, Audie, Jane, and Bob. So Jane should be in there twice in our, what did I? Give me a second. Let me see why my brain is not working here. There we go. I just had something printing there. Too lazy to go figure it out right now. So Jane, Audie, Jane, and Bob. So we've changed this. What I was going to say in all this is that you can actually have a variable that you use to plug in. And this is by far the most common thing, because something that's common here is that you'll have a loop where you're tracking indexes for something, and then you'll want to do something like this. So we're going to use a variable here to index into the list. And then it should do the same thing. Does that make sense?
Yes, it does. Okay,
so this is probably more common. Every once in a while, something that's common, for example, I can give an example from work. We've been writing something that imports code from an Excel file. The customer has things in their Excel file that they want to end up in their database. And sometimes we skip the first couple rows because there's headers and stuff in those rows. So that's an instance where we actually would do something with like a hard-coded index, because we would like skip rows 0 and 1 because those are where the headers are. But most of the time when you use indexing, you'll use a variable in the index. Okay, so I think we've kind of hit the basics there of data types now, immutable data types. We talked about how strings are immutable in Python, which is actually kind of abnormal because strings are mutable in many other languages like Java and C#. We talked about indexing and slicing. We just talked about assigning things to indices. Strings are immutable in Python. The operators, I don't really think I'm going to go over them. I think you probably already mostly know how these work. The arithmetic operators operate on numbers. The logical operators, well, I mean, these actually operate on. So something, I don't want to get too technical here, but these operate exactly how you expect them to on numbers. However, most of them will also work on strings. At least I believe they will. So I'm going to comment out all of the things that we have up here, and we'll do some more scratch examples. So if we have let's say we have a string, and our string is equal to ABC, and then we have another string that is equal to BCE. The first character of string X is A, and the first character of string Y is B, right? So if we were to do something like Z is equal to the first character of X, and then we want to check using a logical operator if that is less than the first character of Y. What do you think that's going to do?
I think it's going to check where it is in the alphabet, really, whether it's earlier in the alphabet than the other.
Okay, so let's hypothesize. So we would expect this to be true, right? Because yes, logical operators return a Boolean, so we did expect this to be true.
Yeah.
And oh well, that'd be why. I was like, why isn't it working? I don't want to look silly. It's because I didn't print it. There we go. So it is in fact the case as we would think here. So this is called operator overloading. You'll hear that term a lot. What it means is that for different data types, you make the operators do different things. Something else that's very common is I come up with more variable names here. We have X, Y, Z, Q, whatever, is to concatenate things. So we would do X plus. I picked confusing strings for this. make X's just A's and Y's just B's. Well, then if we were to do the concatenation, this is called concatenation. It's using the plus sign with operator overloading. And again, all that term means is that we're using the same operator on different data types to do different things. Or sometimes it's the same thing, you know. So the plus operator on ints and doubles both adds the numbers. However, you could define this. You can define this when you make your own classes. When you get into object-oriented programming, you can make the operators do whatever you want. So confusingly, you could make the plus operator do subtraction. You could. You shouldn't, because that's really confusing, but you could, is the thing, is because you get to pick what they do. That's a little bit more complicated. That's one of the principles of object-oriented programming. Deals with polymorphism. We won't even go there, but for anyone who's watching. Okay, so if we print Q now, this we would expect to have AAA and then BBB stuck on the end of this string. So this Q should actually be 6 characters long. And indeed, that's what we get. So those are the operators. Logical operators you will use a lot. Oh, and in fact, I actually missed some. Look at this. Does Python use, okay, a lot of programming languages use these characters for and or. I think Python might actually just be, Python might just be letters. So let's go back and let's do we have Z here, and let's instead say that, let's do it for all of the indexes. So what we're going to do here is we're going to do a really hard-coded version of checking that every character in the string X is less than the character string Y. Okay, so for every character in string X to be less than the character in string Y, that has to be true for each of its indices, right? And right now they each have 3. So so do you agree that all 3 of these should be true?
Yeah.
That should make sense, right? So if we want to check that all 3 of these are true, that's something that is very common when you use logical operators. You don't just want to check one condition most of the time. Usually you'll want to check a combination of them. So in a lot of programming languages, you would do something that looks like that. This would be, the ampersand would stand for a logical and the pipes stand for logical or. And when you do 2 of them, what it means is that if any expression evaluates to false for an and, it doesn't even need to check these, right? Because anytime so if anything evaluates to false, I'm not sure what I said. If anything evaluates to false, you don't even need to check these. Because when you are using logical and, if anything is false, everything is false. Does that make sense, or do I need to say it again?
Yeah. It makes sense.
Okay, and for logical or, the same thing is true, except for a value of true rather than false. If anything is true, everything is true, right? So a lot of languages will use these so-called short circuit operators, which are more efficient when you're running, because you don't actually have to check everything. You just have to, when you're anding stuff, you just have to check everything until you get a false. You have to check everything if it's all true, because, well, you need to verify it's all true. And if you check or, you just check everything until you get a true. Now, Python, I think you actually have to use the words. They're reserved so-called keywords in the language. And so if we run this statement here, you just use the words and or, which makes it more readable, right? But yeah, these super normal in most other programming languages. So if we run this, we would still expect to get true, right? So, and you know what? Let's go ahead and we'll print each of them, and then I'll show you what it looks like when we get one of them that's false. So we're going to print A, print B, print C, and then print this. And this should be true as well. So we should get true, 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 right? Makes sense? Now, let's say that we change this one to C. Well, C is not less than B, right, in the alphabet. And so we're going to expect A to be false now. And we're also going to expect the last one to be false. Does that make sense?
Yes.
Okay, so false, true, true, false. Yep.
Yeah. If one is false, then all the conditions are false. Either the combination of conditions will be false.
That's true. The overall variable, which represents all three of these variables with logical ands between them. Now, if we were to flip this so that we said ors here rather than ands, how would that change the return value of this? I'll give you a hint. You can look at what the values of the three are right now from the first three things printed.
It would make it true again.
Mm-hmm. And that's because if anything is true, everything is true in an expression with logical ors. Okay, so this is pretty contrived. When you're programming, usually you'll have, I'll give you a couple good examples. You might have something where you want to check the type of an object. So we might do something like if my variable dot, is, what would you type check? I mean, we have plenty of things in my project that we would do, but like, let's say just for the moment that you wanted to know if it was a string. And if it was a string, you do something. And if it wasn't a string, you do something else, right? This is commonly what something would look like. Like, let's say it's a string or it var dot has. Often get Boolean values from, oops, this is Python. So you often get Boolean values from functions that you write yourself to check things. Validation functions, is my string valid? Is my string of the type, or not my string, my variable of the type that I expect it to be? Does it have a value within a particular acceptable range for me to be doing things? And usually it's not uncommon for you to check multiple things. Okay, so you're checking conditions, right? And you'll see, I just jumped into this because you almost will always be using the logical operators and stuff in conditionals. So sneak peek. This shouldn't be so terribly new to you because you said you've already been reading stuff, but very common to use logical operators and Boolean logic when you're trying to figure out if you should do something or not. Okay. Are you cool if we move on?
I am. Very cool.
So mutable data types, we're going to skip dictionaries. We'll come back. But lists are, as we were doing up here, lists, probably the most common thing you'll use here for representing data. I suppose one thing I should say is that lists have, let me just keep going with variables. I shouldn't recycle the same ones. That may be kind of confusing. Let's say we make a list of numbers here. So 1, 2, 3, 4, 5. Okay, so lists actually have a lot of things you can do to them. Now, I'm actually trying to remember the methods here in Python. So this is how I would, if I want to say, okay, I have a list in Python, what can I do to a list in Python? Like, can I add things to it? Can I remove things? Can I sort it? Can I filter it? Things like that. This is what I typed into Google. And most of the time, I mean, between these, the Python documentation probably isn't going to have as much explanation as you want. I mean, like, it'll tell you, okay, I can append it, I can extend it. But for you, as someone who's just starting, when you look at this, what's an iterable, right? And you notice that it doesn't define iterable anywhere here. Well, that's not super helpful for you, right?
Yeah, that's one reason I don't like using the website. Yeah.
So one of the issues with normal documentation is once you're a programmer, see, I know what iterable means because I've been programming a while. This is actually pretty helpful information because it tells you everything you need to know and nothing you don't, right? However, when you're first starting, sometimes the official docs can just be confusing because they use a bunch of programming jargon that you're not going to know yet. And I'm not saying never use the original docs because like it is the documentation, if the programmers did a good job, it should be descriptive of what it does. However, W3 schools, if you've come across this website before, this is one of the best places on the internet to learn like HTML, CSS, JavaScript, and they also have a fair bit of Python stuff. So I actually haven't used it for Python because I haven't actually written Python in a little bit here, but you can see that this, better. It doesn't have the word iterable anywhere. So here are some things that I can do for lists. So see they have a list tutorial. That looks promising, right? So they say, here's a list. You can print the list. And if you've ever come across sites like this that have, concepts and then examples, and then you can even go try it yourself like this and just run things as we've been doing. They have a Scratch program and then you can run it. This is really, really useful for when you're learning. So this website, like I said, I've actually used this website an awful lot for like SQL and HTML, JavaScript, and CSS. So I guess, look, first 4 things in the top bar here. Looks like they have Python too, which is nice. And it looks like they have Java and C# and I actually have a lot. So I had always thought this website was mostly more just like web stuff, but I guess they're even teaching. How good is it? Data types, abstraction, lambda functions, even have threads in here. Let's C#. I've written more Java and C# in my life than anything else probably. Do they have? Sorry, this is my own curiosity here. All right, well, looks like they have a pretty decent introduction to all. Ooh, they even have React. They don't have Angular though. Doesn't look like. Anyway, so this actually looks like quite a good resource because I like this website. I've used this website a lot myself, especially for JavaScript. But if they have a lot on Python here, this would be a good place to go because they have the examples that let you mess around with whatever the thing is. So, for example, we're going to look at dictionaries later today. This is the syntax for how you define a dictionary, and they have examples of it. And so something that you'd want to do is get the keys in a dictionary, right? Yes. So loop dictionaries, that's what we'd want. We'd want to get this right here, print all key names in the dictionary. You see that if you enumerate, I'm jumping way ahead to loops, but if you enumerate the dictionary, you get all the keys in it. But boom, you kind of instantly can access most of the stuff you want to do on something from here. Sets, tuples, lists. Sets are another one of the collections that I just find sets are something that you don't have so much in other programming languages because it's really more of a dynamic thing. Actually, for that matter, Python, you can store different data types in the same collection, which is something that you can't do in other languages. That's an advantage of it not being strongly typed. If that doesn't mean anything to you, don't worry. It just means that you could, for example, put a string and an integer in the same list, whereas most languages make you pick a data type for the list. So you might have a list of strings or a list of integers or something like that, and you can't just mix them. I would consider it pretty bad code style if you actually rely on mixing data types, just for the reason that your code will be confusing to most people if you do that. So side tangent. Okay. But anyway, where were we? We were looking for list methods, right? Dictionaries, yes. SQL. Okay, I was clicking around a lot, wasn't I? Well, let's go back. Just figuring out how to use the sidebar. It's probably, tell me if I'm going too slow, by the way. You should tell me if I'm going too slow or if I'm going too fast. Methods you could do on lists. This is just right. Okay.
This speed is just right. Yeah.
So plenty of things you can do on lists here. Let's see list methods. Look, so we're in the list section, and then there's this thing that talks about all the methods. And if you want to see what a method does, a lot of them, if they pick the names well, usually they're pretty good. So append, so you stick an item on the end of the list. A clear lets you remove everything in the list. Now you can read. I'm not just going to read them to you, but you should go through when you're using a data type, and you should figure out, okay, what sort of things can I do to the list here? Now, something else that's kind of neat, actually, is that I'm pretty sure Python is smart enough that it lets you append something onto the end of the list. So let me check something, because in many languages, this will throw an exception, which we'll get to a little bit later. So D has 1, 2, 3, 4, 5 things in it, right? And yes. That means that this has indices 0, 1, 2, 3, 4, right? You follow me so far? So if we do something like, how do you do, did it count? I don't remember. That might throw an error here. So let's try to add something to the 5th position, the 5th index, which will be the 6th thing, right? Well, you know what? I'm being stupid. I have this right here. Well, see, I'm used to C#. So let me see. Python list length. That's what we want to do. I want to figure out, how do I get the length of a list? How do I get how many things are in the list?
Okay, I think it's len.
It's, oh, okay. So just .len.
Yes, I think
Okay.
so.
D dot length. Let's see.
Maybe with the parentheses. I'm not
Oh,
sure.
well, okay. No, this is because, never mind. It's because I had that example that I typed out earlier, but it wasn't actually valid. No, doesn't think so. Oh, it's a method. There we go. Okay, so see, this is super normal, by the way. When you're switching between languages, it's not that I don't know how to program. It's that, how do I do this in this language? Well, when you switch languages a lot, it's not so bad. Like between C# and Java, many things are so similar that you almost don't even have to blink when you switch between them. Python's different. It has cleaner syntax, so you don't have to do curly braces everywhere. And as you see, it uses or and the words instead of like ampersands and pipes. And there are more differences. And also, it's not even that frustrating because, like I said, it's literally a Google away. How do I do X in X? How do I do a for each loop in C#? How do I do, a while loop in, actually while loops are more normal, but whatever, you get the idea. You're always just 10 seconds away from knowing the answer because we have the internet. And so it can be a little bit frustrating, the first little bit where you switch languages. So like I said, this other thing that I was showing you yesterday when I was doing stuff, every once in a while, I had to look stuff up more frequently than I would if I were just going to do this in C#, which is what I use most day to day, because I was like, I had forgotten how you write a for loop in Python where you iterate over indices, because in something like C#, this would be like, oh, here, I'll show you what it would be like. It would be something like, something like list dot. That's what it would look like. And so I'm used to writing things like that. And so I had to Google how to do this, which is, this isn't even a hard thing in Python. Arguably I could have remembered that because I've done that before, but you'll get used to the syntax of one language, then you'll have to look things up. So anyway, long way of saying here that now let's see if Python lets us dynamically add on to the end of lists. Does it not let you call it? Or do you put, is it a method that you wrap it in? See,
I think it's just D. I think it's just D dots len then.
Nope, it's actually just a method that you wrap. So,
yeah, so
I was treating length as an attribute of the list. You see that? In fact, it makes sense that it wasn't that, because remember, we were just looking at our list methods page and you don't see len here, right? These are things that you call on lists, right? And so this is actually, I think it's actually how you do it. So, okay. So Python does do range checking. That's good. I wasn't so sure. So what that means is we're trying to add something to an index that doesn't exist. Now, depending on which flavor of the programming language C you use, if you had a string, strings in C are characters. So like the ASCII characters, they're a byte, and they're terminated by a null character. But it used to be in C that you could just straight up index, wherever you wanted. And so you could do like string of my index and just way off the back. This is called, well, I don't know exactly, that's called buffer overflow. It lets you access addresses that aren't really something that you should be able to. And it's a big security problem because C doesn't do some of this nice stuff. See, so this is an out of range exception. Okay, I'm trying to remember, where was I going with all this? We were talking about,
I think you were trying to do this. I don't know. I think this is the syntax. I'm not entirely sure, but I think this is it.
Well, no. We got this. This actually, so here, I'm sorry. If this wasn't clear to you, we actually did get the length successfully.
Okay. Okay.
So the you do wrap it. You don't. It's not a method of the list. So this is the proper syntax.
Okay.
And so it was throwing an error because we can't index out of range. And I just wasn't 100% sure because I thought, Python has some things that it lets you do in some cases that are more clever than the statically compiled languages. And so I thought maybe, maybe it'll let us, but no. So you can see that I don't even need to use a variable. I can just,
right. Okay.
And so here we should see the length here should be 5, I believe. Yeah.
Okay.
Okay. So how we got onto all of this was that we were looking at list methods, and I was just making one more note on the data types that whenever you're trying to figure out what can I do with this data type, what are some of the operations to use with it? How do I basically interact with it? Off the top of my head, I'm sure there are other good websites. I like this one a lot. Like I said, I've used it a lot for JavaScript. So hey, it has Python. Great. And you see that nothing on here is like the amount of stuff you have to read to understand it. Like, let's say I want to learn how to remove something from a list. They have, an example of the list and how you use it. And then, some notes on like specific cases and whatever. But this page itself is not very long, right? And if you want to learn how to join lists, blah, blah, blah. If you want to learn how to copy lists, sort lists, you see that none of these things, all they have is examples and a little bit of explanation. This, in my opinion, is the best way to learn how to do some of the basics of coding, because a lot of tutorials, like I said, you go take a class, even on one of the open courseware sites, like MIT OpenCourseware, or like one of the massive online open courseware sites like Coursera or edX, and they'll give you weeks and weeks and weeks of really complicated stuff about how computers work, when all you're like is, I want to know how to remove something from a list. And that's why I like this kind of reference site with examples and really clear, concise, here's how you do this in this language. Very, very useful. And for most people, there are some things that knowledge gets you in terms of how you think about computer systems, but I don't think it's worth it. Not for most people trying to get a working knowledge. And so that's my criticism of computer science education. But at any rate, this is where I would reference things for Python. And why I was bringing all this up to pull myself back on topic here is because we were looking at mutable data types. Well, for anything that is more complicated, there's not so many things that you can do to integers, for example. So if we go look here, I mean, well, here's the numbers, but like numbers aren't going to have like so many methods and things you can do with them, right? But collection things, so lists, sets, tuples, dictionaries, all of these have more fun. In fact, we'll see. So we were just looking at list functions, and we said that you could like add things to a list. And here, let's go back to the list methods. So, append, clear, copy, count, extend, index, insert, remove, things like that. If we go look at tuples and we go look at tuple methods, see, it has a lot less, right? That's because you can't change tuples. However, it still has a count and it still has an index. If we go back to lists, you'll see that lists should have both of those as well, count and index. So tuples have a subset of the things that lists do. Lists have a lot more because you can edit them. Sets probably have something that looks more similar to lists. Even more. They have intersect and union, which if you've ever used sets is like a mathematical concept. You know what those are. Okay, so I won't spend more time there. I would say the most important data types that you'll probably use most as collections will probably be lists and dictionaries. I actually can't recall the last time I used a set in Python, but maybe I just wasn't doing the right thing. Lists and dictionaries, I think, are probably the most ubiquitous. Okay, I did put a link here for copies.
I do have a question.
Okay, go for it.
Yeah, this line with the D brackets, then what exactly were you trying to do there? Or were you doing there?
Okay, so what we were checking, this is what caused the error here. What I was going to see is right now, this thing only has 5 things in the list, right? It has things that indexes 0 through 4. And I was going to see if we tried to add something, it index 5. So 0, 1, 2, 3, 4. The index right after this if it would automatically allocate the memory on the computer and let me add it or not. And it doesn't.
Okay.
So what this means is that it does bounds checking. It does, can I do this or not? Now, if we did want to add this, so this doesn't work. We just said that doesn't work because Python doesn't let you just assign to it immediately. However, what would work is if we just said, we're looking at the methods we did, right? And let's say we want to add 6 to this. This actually should stick a 6 in index 5, but we didn't directly access index 5. Well, actually, we didn't actually manually do it, but it added it onto the index for us, right? That was what I was showing there.
Okay.
Or rather showing that you couldn't do.
So I get it.
Okay, great. I'm going to skip this. I left a link for you. I went and found the link this morning. I hadn't yesterday. For now,
Okay.
we're just not going to worry about it. I'll worry about it when we encounter bugs with it that pop up. Copying, and you should not feel bad about yourself if you sit here and you think about it and you get really confused, because everyone does. This is one of those really confusing things in programming, and so specifically Python, like I said, it's actually worse than many other languages in this regard for copies, because things in Python, as we'll get when we talk about functions in just a sec, every time you pass a variable around and you make changes to that variable, it propagates. Basically, you have to be very specific in telling it, hey, I don't want this to change other things. So Python has what are sometimes referred to as side effects more than other things. You run a function and it changes something somewhere else that you hadn't really intentionally meant to change, but it does it anyway. And a lot of other languages, let me see, do I want to go there? I certainly could. Let me ask you, actually, what do you want me to talk about next? Do you want me to talk about functions and programming with functions, or do you want me to talk about debugging, or do you want me to talk about for loops, while loops, switch statements?
Okay. I don't think I know anything about debugging, breakpoints, step over, step into, continue. I don't know anything about all that stuff, but I know something of functions and conditionals and loops, but that doesn't mean I've benefited so far from stuff you've already said that I already know. So you would be introducing the debugging stuff to me, and you would be refreshing the other stuff. So I'm quite fine either way.
Okay, I mean, and we're going to cover all of this. All of this stuff is, core essential, non-negotiable. So it doesn't really matter. I was just wondering if there was something specific you wanted me to do order-wise, because otherwise, I don't think it's going to take us like weeks to go over all of this too. I'll tell you what, let's skip debugging. I actually realized this the other night. I was going to have us do it early just because you need to get in the habit of it. I'm going to do it after we do functions, though, because one of the parts of debugging step into requires you to have functions.
Okay.
Let me pivot straight into functions. So I was saying that copies and understanding copies relies on this idea that Python changes things that it shouldn't. Maybe that doesn't mean too much to you right now, but let me give you an example here. So
does it have anything to do with global and local variables and whatnot?
Yes. Let me give some definitions, and you tell me if any of these things don't make sense. So if I say that functions have scope, do you know what that means?
I think I could say something about that. I think it means that functions can be limited on with respect to what they are supposed to do and where they're supposed to do it. So they could apply to a large block of code, or they could apply within a small loop or something like that. That's my conception of it so far.
You know what, I should not say outside variable, I should say. Okay, so what I'm doing what we're going to see is, does setting my var equal to 4 inside this function, does it change this out here? This is what, so when we say scope, generally in computer programming, what we mean is what variables can I see at this point? So I'm inside my function. I'm not in the global namespace. Do you know what the word namespace means generally? Does that mean anything to you?
Space?
Yeah.
No.
Okay. So if let me think about the best way to explain this. So when I'm inside of a function, I'll have access to the things that I pass as parameters of the function. You're familiar with that, right? So
Yes.
if I pass things to the functions, then I can access those variables, and I can use any variables that I define in the function. However, depending on the names, depending on where you are, you may not be able to access anything outside of the function. That's what we mean by scope. And right now, I'm going to show you some of the things that makes Python sometimes tricky to program with, and bug prone for people who are used to statically compiled languages. So outside here, you see how we set the value of my var to 5. So this print statement we would expect to be 5, right? And this statement inside the function, I'll actually need to call my function here, right? This statement inside the function is 4. So we'd expect this print statement to be 4. So now I'm going to ask you, what do you think the value of my variable is after this function executes? Is it 5 or is it 4?
Okay. I would expect it to be 4.
Okay, you'd expect it to be 4 because it's 5 up here, right? And then this function is getting called. It's getting called. You know what? Let me redo the order here, so it'll make it more conceptually simple, right? So first we're going to set the value to 5. Then we're going to print it. Then we're going to call this function, which you see sets the value to 4 and prints it. And then what's the value? So you said 4, right? Let's see what actually is at the bottom of what we print out now. It's actually 5. And the reason for that is because of this thing that I'm calling scope. So when I make a variable out here, it is in what we're going to call the global namespace. It's in the set of variables out here. It's not inside this function, right? It's not bound
to this function, yeah.
So here is where some understanding of how programs really execute helps. Have you ever heard of something called the stack? Does that sound familiar? A stack frame. So when a function gets called, it's as if you put a pancake on a stack of pancakes, and your function is the top pancake. And once your function gets done, it's as if you remove the pancake. You may also hear an analogy used of like trays in a cafeteria. So how about a queue? Have you ever heard of a queue data structure or a stack? So stacks and queues are kinds of data structures. So a stack has, this is another website I've used, Geeks for Geeks, Tutorials Point. Those are both websites, probably a little bit more technical. So for people who already have some programming. So stacks have 2 operations, a push and a pop. How functions actually work, I'm being very hand wavy here, but anytime you call a new function on the execution of your code, you pop something on the stack. What that means, here, let me see, memory of a program. Let me see if I can get a picture. So in system memory, do you know what system memory is?
I think.
Okay, so basically like your computer has an amount of space it can use.
Right.
So this is like memory addresses. This is the space. The
physical location, right?
Yes, exactly. So the stack, which is what we're talking about in terms of functions, every time you call a new function, you add something to this. And I'm not going to go much past the pancake or tray analogy here. You see one of these things, that's a function. And inside that function, you have a set of variables. The function has its own information. That's basically the idea here. That's basically what scope means, is that this function here that we're working with, it has its own stuff, and things that aren't the function can't access its stuff. and the function can't access stuff outside of it. That's the idea of scope. And this helps prevent bugs. This is not a bad thing. You know, sometimes new programmers think it's so frustrating. Why can't I access this other thing outside of my function? That makes my life so much harder. Now I have to like pass it. I have to pass it as an argument or things like that. Well, the reason is any other time you were doing stuff out here and then you had a variable in your function, the variable elsewhere would get changed. And that'd be so confusing. This will already happen to you, as we'll see in a second, Python. This will already happen to you more than you want it to, where you have these side effects, you have something that gets changed and you don't know where, and it's so frustrating because the thing, it doesn't have the value you expect it to, and it can cause really, really hard bugs to track down. So now what I'm going to do is you see how we declared this variable inside the function. So variables inside the function, you can call them function variables if you like. They are inside the function scope. Nothing outside the function can access them, and they're just the functions, right? So now let me actually pass my var as a parameter. Capitalize it, I did. Okay, so what do you think it's going to print now?
I think it will. Okay, this is. Okay, we'll print. It should print 4 now.
At the end, that's really what I'm asking about. At the end, it should print 4. Okay, and we'll see. And oops, well, that is because I forgot to pass it. So I put it in the definition of the function, but then when I called the function, I did pass it. That's what that means.
It still prints 5. Okay. I'm not sure. I'm not sure. Okay, let me think for a second. So does it pass when you put it in parentheses like that? Does that make does that put the variable from the global scope into the function? Does it do that?
So let's go take a look at this link to try to explain what's going on here. This website, also helpful links that I've seen here. Oh, actually, that's the copying link. Did I? No, that's the wrong one. It's this one, pass by reference or value. So as I say, Python is actually more confusing here. Well, I'm saying this as someone who's biased because I've done a lot of languages. And you know what I realized, Audie, was that I was giving you a bad example because the data type that we're doing here is an integer and it doesn't change. And so I'm even confusing myself here at this point because I was actually expecting this to print 4 just like you. But the reason for why this is, let me do something better. So we're going to change my var from an integer to a list of strings, okay? You see that all we've done here is change it from an integer to a list of strings. Now, I believe, if my understanding is correct, that what this should print now is BBB, even outside of the function. So the very first time we do things, it's going to print AAA. Inside the function here, it's going to print BBB. And then once we're outside, I think it should also print Bs again. It doesn't. So it means that my understanding wasn't great either. So see, it confuses me. It is confusing, right?
Yeah.
Okay. You know what? It's because I defined. I got it. It's because I am defining a new variable inside of here. If I do this instead, Does the change I make mean anything to you? I think I get it now. But what's the difference between these two lines here? This one? This one.
The update bit seems to me to mean that the variable is being changed within the function.
Mm-hmm. So here's the thing. Right now, I have a variable coming in as an argument, and then I'm making a variable inside the function here. Because the second that I put this as a variable and then put an assignment on it, I'm making the variable, basically. I am saying that, hey, this is my function variable here. And then anything that I do to that variable thereafter is going to be bound just inside the function. And that's why it doesn't change things outside. Now, if I don't make that variable, and then I use the value of this, the value of this is coming from outside. It's being funneled into the function, basically. So this is actually not, for Python, again, very critical for me to emphasize, for Python, this is not just the functions variable. This is like a hole in the function, if you will. You are putting something through the hole. You're saying, hey, function, I have this variable. You can make use of this variable, but it's not yours. That's, in Python, how data passing works. Does that make sense?
Yeah.
If it doesn't, please say no, because this is one of those things like shallow copies, deep copies, confusing. Argument passed on functions and mutability, confusing. This is a confusing thing. So don't just smile and nod. If it doesn't make sense, you should say it.
I want to run through how I actually understand it now, so you can tell me whether I'm understanding it correctly. But at this point, I'm seeing that, just like you said, with the parentheses, it's saying here's something you can use in the function.
Mm-hmm.
The function can make changes to the variable within the function, but those changes don't apply outside the function.
So if you use the version that the function itself is inheriting from outside, they actually will apply outside. This is why I was confused a second ago, because I thought I was doing this when in reality I was doing this. Now BBB. So you see, this was what it printed before. We should expect BBB on both the first and the second line now.
I think the update thing is not Python.
This is definitely Python, but he's using a set. He's using a set, not a list.
Okay.
Well, you know what? We can update that. We can make this do a list. So rather than update, something that I know is a function of lists in Python is clear. So let's say we want to delete all of the things in the list here. Let's say we want to clear the list. And then let's say we want to append just a single B. Okay. So now we expect the list here to be just 1B. And this list outside should be 1B too. But this list outside, this variable is outside the function, right?
Yes.
This is the takeaway point that I was trying to get at. And I'm sorry that if I made it even more confusing, because I confused myself there for a second. But this is that idea that things that you change inside functions can change things outside functions.
I see. I think I understand now. It takes
languages,
the function.
In languages other than Python, you have to try to do this. The default behavior is to not change things outside of functions. This link that I have here, let's put, I don't know why I'm doing this above function. I should be doing this below the function subheader. This link right here, I think it's pretty good. On this website, I've used this one before as well. Python guides, real Python. These are all things that come up on Google searches for something. But we are looking for pass by value, pass by reference. Okay. So those things are jargony terms. Pass by value means that you make a copy of the variable when you pass it to a function, and you don't actually change anything about the initial variable because what you're working with is the copy. Well, in Python, I'm going to be a little hand wavy. Technically, Python doesn't actually do what I'm about to say, but for your understanding, it's easier if you just understand that it does. So the other possibility is that you have a variable that exists outside the function, and then the function's actually using that variable. It's as if it has the real thing. It's not making a copy of it. It's actually using the real thing. Anyone who's angry at me right now, you can forgive me. Python does something a little bit different, actually, called pass by object reference, but we're going to ignore that because it just doesn't add any value to you. So it's basically Python takes the value that you give it inside of a function, and then unless you specifically make a new variable inside the function, it will change this one.
Okay. I understand.
Yep. So something that is more common, I think, if we wanted to copy this, I will show you. So we said that if we reassign this variable, then it's going to change the one outside, right?
Yeah.
And if we just do things to the variable, it doesn't. Or sorry, it's not going to change the one outside because we made a new variable inside the function. And thereafter, anything we do. So if I uncomment this again, this now the xi thing should be AAA. Even though we're passing in a variable, once we've defined the variable locally inside the function, all other references to this will be referencing the variable that we defined, not the variable coming in from outside.
Okay. Okay.
It's really tricky, right? That's the only difference.
So by assigning the variable a new value within the function scope, within the scope of the function or whatever, we kind of don't do anything to the variable itself from where it comes. Like in the global scope, it doesn't affect the value of the variable. What I'm saying is, when we reassign some value, like in this part, this line that you commented out, when we reassign a value to that variable, the same variable that was passed into the function through the parameter or the argument, it doesn't change the variable outside of the scope of the function.
So if we define it, if we define something inside the function and then do operations on the thing we've decided, the thing that we've assigned inside the function, it will not change the thing coming in from outside the function. That is correct.
Okay.
So now let's try something else. I'm going to move this from above both of those lines to just be above the second line. Let's see how good your understanding is now. So
what I suspect will happen.
Execution starts right here. So you agree that this one should print A's, right? 3 A's.
Yes.
Okay. Now we are in the function. We have in a parameter, this is the real one coming in from outside. And then we assign one 2 lines down. So now what does this print statement print?
Okay. It will print 4 B's.
4 B's. And you want to try to explain to me why?
Okay. When it takes in the variable from the global scope, it clears everything so that there's an empty list. It creates a new list with 3 B's in it, and then adds 1 more B to that list. That's what it will print at that point.
Okay, now this list that you said it creates, where is that list created? Is it
within
global
the function
scope? So it's in function scope.
Oh, so, okay, no, I think that list will also be in the global scope because it performed it acted on the variable that was coming into the function. It cleared it. So I suspect that what it will print in the global scope will be the same list of.
By the way, I'm not asking leading questions saying you're wrong. I'm just trying to see how
I understand.
Yeah,
I understand. I that's trying to just work through it myself.
Okay.
So I think that
so you think
the function
that because we're changing something coming in from global scope, that for the rest of this function, what we do is going to be related to global scope. Is that an appropriate summary of what you just said? So
yes.
Actually, before I do anything else, I want to run and see what it is. That's what I thought. So that's actually not the case, because if that were the case, then we would have expected to see B's down at the bottom as well, right?
Oh, okay, yeah, but I actually was a bit confused whether it would print an empty list in the global scope, like with the last print statement, whether it would print an empty list or whether it would print the 4 B's. Because the first thing it does is actually clear out everything that's in the list in the global scope. So I don't know. What I'm seeing is that it prints an empty list. So I think in the global scope, the variable has actually turned into an empty list. What happens within the office?
Do you want to try to think through it a little more, or do you want me to just explain it?
I want to think through it a little more.
Okay. Let me do something that might help. Okay. So I'm not going to change any code. I'm just going to put a space there.
Yes. So how I see it right now is the variable from the global scope comes into the function and it's changed by that clear method. So what exists in global scope right now is an empty list.
That's correct.
But within the function, the list is changed into the 3 B's. Then the 4th B is added to it, and that's printed within.
You say the list is changed. Is this the same list, or is it a different list?
Okay, no, it's a different.
Let me ask again. Remember how
a different list is created? Yes.
Yes.
A different list is created.
Let me see if I can find this again. Remember, I said functions are like this, right?
Yeah,
Any variables that a function has live on its pancake, live on its tray, right? Does the global variable live on a pancake or a tray? I mean, boy, if someone heard me asking you this question, they'd be like, what is this man teaching? This is not programming. Do global variables live on a pancake? No, they don't. But the point is, when this variable inside the function gets created, all variables that are created inside functions are specific to that function's little slice. Right?
Yes.
They live inside there. And so the second that we do an assignment inside this function, that variable here on after is referring to the function variable. Yes. But before we do that, this previously to this in this function does not exist. So this variable, when we do the assignment, we make a new function variable, and then we do things to it. And then when we print this variable inside this function, inside the scope of this function, that's the jargon people will use. Inside the scope, the namespace basically just means what things are accessible within the function. So variables you make inside of a function are quote unquote in the namespace of the function. So namespace and scope, I don't want to say they're exact synonyms because people tend to use them a little differently, but very, very similar concepts here. So this is a new function created inside this function scope. So on the pancake, on the tray, if you will, to use our understanding here of how functions are built on a stack. And then once the function returns, the function on the stack is like popped, it's removed. So new variable that the value's changed, but we had already, before we made a new variable so that we could no longer use this one up here because we called it the same thing. Well, before we did that, we cleared the one out there. Now this is all made much, much, much clearer if we were to do something like this, right? Because now we see that, okay, we're changing this one, and then we're making a completely new list. This is actually what's happening. Oops, I just pressed my screen. This is what's actually happening conceptually. However, if we delete the one and we call the variables the exact same thing, that same thing is still happening. Exact same thing, except we didn't update the names, right? Except they just happen to be called the same thing in English to us. However, to the computer, they are not the same thing.
Two different things, yes.
So I think that's actually, kind of wish I'd started with that. Probably would have been a less confusing way to explain this. This is actually what the computer thinks is happening. You're making a function variable called whatever is on the left-hand side of this assignment operation, but that's completely separate from this one. It just so happens that if you call it the same thing, that's where it leads to all of this confusing business, right?
Yes.
However, this is not, it's not for no reason that we're going over this. Why I start, rather than just being like, okay, Audie, I'm sure you can make a sum function. You already know how to do that. I'm pretty sure if you've ever seen functions before. This is the hard part of functions because anyone can make a function that adds two numbers. But a lot of people want to say that this should be valid. They should say, hey, I passed in my variable. Why can't I reassign the value of my variable? You see? Because a lot of people would want to be able to do this. But the second that you do this, you're no longer talking about the global variable. You've made a function variable, right?
Yeah.
So you see why that's so tricky. You see why that's so confusing. And this is the source of a lot of bugs for new developers and even experienced developers. Like I say, coming in from languages that don't have this exact form of passing of arguments and methods, they'll get confused. I see, I got confused by it when I was trying to explain it to you for a second. I mean, I caught myself eventually once I went and cheated and looked at the external website explaining all of this, but
Yeah.
do you think you understand now? If you get confused,
Yeah, I do. But then that a question does arise. If you want to use the global variable within the function, how would you do that then?
What do you mean use it?
I mean, once you make an assignment to that variable within the function, you've created a new variable, you've created a new thing. What if you still wanted to use the one you got from outside from the global scope?
You have to use the methods of the object that you get. So in the example from this real Python example here, they use a set. Now, a set has a function called update.
Yeah.
Okay, so let's see. I'm going to give you a minute. Take a look at this and see if you understand. See if you understand this example here.
Okay.
Is that big enough? Let me see if I can open that in a new tab so you get the full thing. And you can see what actually prints out down there.
Yes. Outside of the function, in the global scope, the set that's a set, right? Not
yeah, these are sets, but notice that they're actually exactly the same, right?
So outside in the global scope, it starts with this variable student with a set of three.
Yep.
Okay. Then within the function, it creates a new set and updates the old set with the global variable with that one. But in updating it, it looks like it creates a new variable student.
So let's say we don't know what set update does. Okay, well, we're going to go to W3 schools. Like I mentioned, we're in Python. Okay, so we're on Python sets. We want to go to set methods and we want to go click on set method for update. See how I got there? W3 schools, Python sets, set methods, update. Inserts. So it's kind of confusing. You might think update would change the value of it, but what update actually does is it inserts the items from set Y into set X. Okay. So there you go. So we have set Y here is, or new. The new set is Sam and Steve, and we're gonna, when we update that into student, we're gonna add this set into the previous set. So yes, it makes sense then that inside that's the value, but you see that outside that's also the value, right? Now, now in this example, let's go look at the other case that he does. So you see how these are different? The first case,
they're the same.
No. This picture and this picture are not the same.
Oh, okay.
So in the first one here, we make a new variable and then we update the old variable value without doing an assignment, right? We never
Okay, without doing
we
an
never do
assignment.
student equals blah. Without doing an assignment, we update the value of the old one. Over here, we do an assignment, right? And then you see that they're different inside and outside. Because the second we do an assignment, this becomes a function variable.
So the function can change the global variable by performing some on it with methods. But once it does any assignment, it's actually creating a new variable.
That's correct.
Within the function scope. That does not apply outside of the function scope.
That is correct.
Okay. So if we're passing variables from the global scope into the function, we have to be aware that we can change the global variable in the global scope by things we do within the function.
That is correct. And the reason why I'm emphasizing this so hard is because this is a problem. I don't want to say it's unique to Python, but Python does this by default. Most other programming languages do not do it by default. And so beginning programmers in Python commonly have bugs related to something updating in a list they pass or something that they didn't think was being changed. That's why I'm harping on this so much, because you will find bugs if you're not careful doing this that you just wouldn't get if you were programming in Java or C#, because you can do exactly what we're talking about here. It's called pass by reference is the jargon for it. So we're talking about mutable data types that have methods. Those things are objects. This is where some of that lower level understanding can help a little. Objects live in the programming world. They are let me think about the best way to do this. So do I still have the picture?
Live in different neighborhoods.
Yeah, basically. So primitive types like integers they're just a value. Like they don't have methods and stuff. But typically when you pass a reference to an object in a language like C or C++, what you're doing is you're passing a pointer to it. A pointer literally points to the memory address. Now, modern computer operating systems use dynamic memory, and they also sandbox programs, so they're not using actual physical memory. So there's some additional like layers there, but basically you're giving it the actual memory address of the thing that you're working on. And so it kind of makes sense that if you give it the memory address, well, then you're going to be doing things to the same one. But by default, most other programming languages, you can see a handy dandy summary chart here dealing with some of the things. Pass by reference is what we're talking about here. Let me actually just read this. So pass by reference is used in some programming languages where values to the argument of the function are passed by reference, which means that the address of the variable is passed and then the operation is done on the value stored at these addresses. So you give it the actual variable coming in from outside, right? I'm being hand wavy. This is basically what Python does. Python actually does something passed by object reference, but don't worry about it. Python acts as if it's doing this, okay? Pass by value means that the value is directly passed as the value to the argument of the function. Here, the operation is done on the value, and then the value is stored at the address. Pass by value is a copy of the variable. So by default in Java, for example, when you put something as an argument of a function, you cannot. There is actually no way for you to change the variable outside of the function. You can't do it. It's simply impossible. Because when you pass a variable, what's actually happening is that you are making a copy of it, and then you can do stuff to the copy. You can do whatever you want to the copy, but it's not going to change the original. So in languages like Java and C#, if you want to change the value of something external to the function, a variable outside of the function, inside of the function, you have to explicitly use the syntax to do this. So by default, the default syntax of just, passing a variable in passes by value. In those other languages, if you want to change something, to have side effects, to be able to update the thing outside of the function, you have to, I think in like C, so in C, you can use pointers, which are really confusing. I won't even tell you what those are. You can use pointers, or I think you can use the ampersand operator in C#. or C++, sorry, to pass by reference. You can do it, so it's not impossible. It's impossible to, if you are passing by value, it's impossible to update things outside your function. So maybe that's more information than you needed for just Python, but the second that you start using other common programming languages like C# or Java, this will become relevant. So that's why we're kind of going over it generally. So I got to run.
I think I appreciate it because I was confused about what happens to a variable when it comes into, a function. So it's clear to me now that in other programming languages, if a variable comes into a function, it's likely that it won't be affected by operations that are carried out on it because it's just a copy of it that comes into it. Yep. But in Python, whatever you do within the function is going to, if you perform methods, if you call methods on that variable, what's I don't know the jargon for it, but if you do anything to that within the Python, within the function in Python, then it will change the variable in the global scope, and that's it's a risk. It's a risky thing to do in programming, to do it deliberately, or else we can cause consequences.
Well, I think perhaps the best way to put it is if you do anything to the variable except for reassigning it, right? Because the second you reassign it, it becomes a function variable. Or rather, the second you reassign it, you make a function variable with that name and you overshadow the name of the variable that you previously had.
It overrides it, yes.
So this variable doesn't stop existing. It's just you are no longer able to reference it because you made another variable with the same name. So my recommendations as a programmer here on how to avoid bugs with this is to, if you ever make a variable inside of a function, do not name it the same thing as a global variable. Do you need me to repeat that, or did you get it?
Yeah, I got it. It's actually what I was thinking would be the best thing to do. Just don't name the function variable the same thing as the global variable.
Because if you don't do that, then there's
no confusion.
You know that because you're programming in Python, which acts as if it's passing things by reference, then when you pass something in, you are able to change it, and the changes will persist outside of the function, right?
Yeah.
So because you know that that's how Python acts, you won't be confused by it. That's always how Python acts. It's not like it's inconsistent. So you can change things inside functions, and the changes will persist. That's different than many other programming languages by default. However, that is how Python works. But that means that if you ever make a variable inside the function that you're doing stuff to, if you just name it differently, well, then it'll be super obvious that that variable only exists inside this function, right? And you won't get confused. So perhaps we just spent a lot of time explaining something that I could have just told you the rule, right? I could have just told you, hey, never name something the same as a global variable inside the function. But then you would have always wondered why, right?
Why exactly?
So
I'm glad we worked through it because I didn't like the confusion about what happens to a variable within a function and when it comes into a function. So at least now I know why it prints an empty list rather than 4 Bs, a list of 4 Bs or a list of 3 A's. I can see why it does that. And yeah.
Okay, ready, Audie? Now we're going to do the rest of functions. If we have a function called
sum, do you have that much time?
I do not, but I'm making a joke because well, okay, I can't actually use that because it's a reserved word, but
okay.
The end. Now you know how functions work. I mean, like the rest of functions compared to what we just talked about is really, really easy, right? Functions return something. You can return stuff in functions. Most other programming languages make you return a actual type, but in Python you don't, because Python lets you be lazy. But you take in the arguments, you can do stuff with the arguments. And by the way, this mutability stuff, this only really affects things that are reference types to begin with. Some things are not reference types. Integers are not reference types.
Okay.
Integers don't have a memory address. Now, if you want to get technical, it's because integers, where's my picture? integers are not stored on the heap. They don't have this addressable location because integers are only ever associated with stack frames. They're only ever, because they aren't allocated separately in memory, they don't have their own memory addresses in the same addressable way that the other things do. So anything that's a quote unquote primitive type, so that would be like integers, doubles, Booleans. I actually am not sure about tuples. You can't update tuples anyway, so you won't have like a confusing issue of them getting updated unexpectedly. But you can't change these, right? And so you don't have side effects from these things. It's just from things that are mutable that you can update. So most probably lists and dictionaries is what you'll be using. But all right, well, we'll talk about just a couple more peculiarities with functions tomorrow, probably. But I think we've handled the tricky bit because the rest of it is just like, what exactly does it mean to return something and some other stuff.
Basically, just yeah. I imagine it's just solving problems with functions and seeing what you can do with them.
Right. And so, but this is by far the tricky part with functions, always is. So I think we'll cut here for today. And when we pick up tomorrow, like you said, we'll do some practice on just functions generally. So that'll be it for today here.